Welcome, my dear students. Today there is a very lovely topic from is matter around the sphere of ninth class. That is classification of mixture, learning outcomes, solution, colloids, and suspension. Yes, here we will classify mixture on the basis of size of the particles of solute. Yeah, size of particle, when we check out solution, this mixture is classified into three types, right? So what is these three? Solution, colloids, and suspension. Solution is also known as true solution, right? True solution. So here the size of the particles, that is the solute particle, is less than 1 nanometer. Less than 1 nanometer. Now what is the solute? Dear students, when we mix the components to form the solution, it can be two component like salt in water. It can be three, salt, sugar, water, right? Or four. When there are two component, it is known as binary solution. Binary solution when there are two component. Yes, one is solute, another is known as solvent. That particular component which is present in the small amount, that is known as solute, and another which present in large amount known as solvent. For example, salt in water. Salt is present in small amount, that is known as solute, and water is present in large amount known as solvent. Right? Okay? So when the size of the particles of the solute is less than 1 nanometer, it is known as solution. This is known as true solution. Right? So example, salt in water, sugar in water. Yeah. What are the some other characteristics of this true solution? It is homogeneous in nature. Right? It is homogeneous in nature. Component distributed thoroughly, equally, uniformly. Transparent. It is transparent in nature. Right? I am having a solution I have prepared. This is your solution of salt in water. I have dissolved here NaCl. I can put more, right? NaCl I am having. I will dissolve. Yes. So we are preparing salt in water. Now solution is ready. Now what are its characteristics? What are the characteristics? It is homogeneous, right? You will taste from the any corner, it is equally sweet, equally salty. So it is homogeneous, transparent. Transparent we can see, right? From this side to that side, it is visible. So it is transparent. Yes, it is invisible. Size of the particles are not visible to us. Particles of this true solutions are not visible by the naked eyes. Right? Not visible by the naked eye. Can we separate the particles by the filtration? Let us check. Yes. We are having here this funnel, tripod stand, okay? Filter paper I will use, right? How to use? This is your filter paper. Fold it semicircle, then 1/4. Then we will use it, right? This is your funnel here. Now let us check it. Can I separate it out? Yeah, process is going on. Yes. So after this, I will see particles are not there Particles are not visible, and in this filtrate there is same type of solution we are having. This is the remaining I have left. It was here earlier, it is after filtration. So there is no difference. So we can say that the particles of a true solution cannot be separated by the filtration. We cannot separate. They are not visible. We cannot separate, and the particles do not undergo Tyndall effect. So what is Tyndall effect? Right? Tyndall effect is when we pass the light through the solution, if the path is visible, if the path of light is visible, right, that is known as Tyndall effect. Why this path is visible? Right? When the light gets scattered. When the light gets scattered. Right? So for that, we need a particular size of the particles which can scatter the light. When it gets scattered, what happens? Path is visible, but it does not show that path of light. So Tyndall effect is not given by true solution. This is all about true solution, right? Now this solution, further when we prepare the solution, it is of two types, saturated and unsaturated. Saturated is that when we will prepare solution, what happens? If more solute can be dissolved, then it is unsaturated at a particular temperature. But if no more solute can be added, mixed up, it is known as saturated at a particular temperature. And with increase in temperature, saturated solution becomes unsaturated. Right? So it is of two types, saturated and unsaturated. So this is about the solution. Now the second is your colloidal solution. It is also known as Sol. Here the size of particles is between 1 nanometer to 100 nanometer. Right? 1 nanometer to 100 nanometer. And other properties, it seems homogeneous, but it is heterogeneous. Right? Let us take the live example. I have prepared milk in water. Milk in water, right? Now see, it seems homogeneous, but it is heterogeneous. Some particles are there which is settled down. Yes. So it seems homogeneous, but it is heterogeneous in nature. Okay. And it is also transparent. Right? Not too much transparent, but it is there. Shows some properties of the colloidal solution. Right? And particles are not visible to the naked eye. Microscope can see it, but we cannot see by the naked eyes. Right? Particles are not visible, and it shows Tyndall effect. This effect, Tyndall effect, where the scattering of the light due to which path is visible to us, right? For example, scattering of light, this Tyndall effect, we can see early morning or when the sunlight comes through a hole to our room, right? So that path of light is visible. That is known as Tyndall effect. When projector in cinema hall, right, it shows the picture, the path is visible of the light, that is Tyndall effect. So many daily life observation phenomena are there. Okay, so this colloidal solution seems homogeneous, but it is heterogeneous in nature. It undergoes Tyndall effect. Past particles are not visible. Let us see, can it be separated by the filtration? Right? So I will use the same equipment again. Okay. Filter paper we have to use first. Filter paper we have to use it. Yes, we are using it. Fine. So let us see the particles. Okay. So now see particles we cannot separate it out. There is no particle here. Okay, particles are not visible, and this filtrate is there, it is of the same type. Filtrate is of similar type, right? So we cannot separate. So what is the conclusion? We cannot separate the particles of the colloidal solution, but it shows Tyndall effect. How differentiated here? Size is different, but and it shows Tyndall effect colloidal solution. It does not show at all. Okay. For example, your smoke is your colloidal solution. Milk in water is colloidal solution. So many examples. Butter, cheese. These are also colloidal solution. Emulsion. Milk is also known as emulsion. It is colloidal solution. Different type of colloidal solution depending upon the different type of the components. Yes. Now the third one is our suspension. So why it is known as suspension? Because particles get suspended. Right? Here the size of the particles is more than 100 nanometer. These are largest size particles, and due to this reason particles are visible. Let us take an example. So I have prepared suspension by dissolving sand in water, right? Sand in water. Now see, particles are visible. Particles are visible to us. Yes. So particles are visible here, right? It is heterogeneous. It is heterogeneous. Two different phases are there, right? You can see. So after some time here the size of the particles are more here, right? And at the top less particles, sand particles are there. Fine. So what about the stability? Stability I will discuss at last. It also shows Tyndall effect because size of particle is in a particular range where Tyndall effect can be shown. Lights can be scattered, so path is visible. So it also show a good Tyndall effect, right? What about can be separated? Let us check. Can be separated through the filtration. So again same process, filtration. Let us tie small amount of sample. Yes. You take it on. Leave it. Yes. Now see dear students. Now some particles get separated. Particle in the filtrates are not there, means they are, where are the particles? You can see this filter paper, the particles are here. Sand particles are here. So we can, it means we can separate the particles of the suspension by filtration. This point also differentiated. Second, size of particle is visible. Now it is heterogeneous, it shows Tyndall effect, and one point which we have to discuss, that is about the stability. Now this solution, this your suspension is least stable. Least stable means when I will, after mixing this sand particles or any this solute in the solvent, what will happen? After some time the particles settle down. There is not remain as a solution. There is no mixing. All the sand particles, solute particles, they separate out and they settle down. They get sedimented. Right? This is known as sedimentation process. So, you see all the particles are gathering here, right? Collecting here at the bottom due to the gravity. So, this is known as sedimentation. This is there in the suspension. So this is about the suspension. So, and this is the least stable. Most stable is your true solution. So it is known as true solution. It does not change its nature, right? And it is mediocre. So This is the true. And this is suspended. Which are not true. They get suspended at last for their profession. So we have to true. Yes. So this is all about your this classification of mixture depending upon the size of particle. So at last but not least, my dear student, you are unstoppable. Never underestimate your power because we are infinite. We have hidden talent, hidden energy is there. We are bottled up energy. So find out your potential and move on. Full this universe is for you to find out your all the hidden values. You are unstoppable. Nobody can stop you until and unless you just become your own break. Right? Negativity should be throughout. So be your unstoppable. Go ahead. With this, I take a leave. Thank you.